Welcome to the GCSE Maths Advantage. I'm Dr. James Carter, and every episode I'm going to break down one topic, show you where the marks are, and give you a quick win you can use in your next exam. Whether you're targeting a grade 7 or pushing for a 9, let's get into it.
Hook. This one notation slip cost more students marks on vector questions last year than any single arithmetic mistake. It sounds small, but it changes the direction of the arrow, and the mark scheme will take it away. Stick around and I'll show a tiny visual trick that stops that error cold. Before we start, a quick promise. No heavy jargon in the next minute. If you can draw an arrow and count 2 boxes to the right, you can do vectors.
The concept. Let's make vectors visual. Think of a vector as an arrow drawn on a diagram. The arrow shows both direction and distance, 2 things you've already practiced with coordinates. In GCSE notation, we often write position vectors as columns. For a point A with coordinates 2, -1, we write its position vector as 2, -1, or simply 2, -1. Say that aloud. The vector to point A is 2 across, -1 down. Why column form? Because it lines up with how we add and scale arrows. If one arrow is 3, 4, and another is -1, 2, adding them means adding their components. 3 plus -1 is 2 across, 4 plus 2 is 6 up, so the new arrow is 2, 6. Visual rule, place arrows head to tail to add them. If you prefer numbers, add the columns. Both give the same result. That head-to-tail picture is your mental checklist when numbers get noisy in an exam. Scalar multiplication is just stretching or shrinking the arrow. Twice the vector, 3, 4, is 6, 8, twice as far in the same direction. Negative scalars flip the arrow. -1 times 3, 4 is -3, -4, pointing the other way. This tiny idea, multiply components, is used in every vector question you'll meet.
Now, the standard exam form you need to recognize the vector equation of a line. If A has position vector A and the direction vector is D, we write R equals A plus lambda D. Read that as any point R on the line is the point A shifted by some amount lambda of the direction arrow D.
Common slip alert. Students mix up the order when finding the direction vector between 2 points. Vector AB equals B minus A, not A minus B. Do that in your head and you'll get the wrong sign and lose method marks. Let that sink in. The exam technique. What does the examiner want? For a typical 2 or 3 mark vector question, you'll usually see this breakdown. M1 for correctly forming a vector using components, M1 for writing the vector equation in the form R equals A plus lambda D, and A1 for a correct final answer presented clearly. If you miss the order when you form D, you lose that first M1, and often the A1 too.
Important notation rule. Use column or bracketed coordinate notation and write the parameter, usually lambda or t, explicitly. Examiners look for that form. Writing a rough sentence without the vector r or the parameter won't pick up the method marks.
Also, and this is exam gold, show your subtraction when you find a direction vector. Write AB equals B minus A equals 5, 3, minus 2 minus 1 equals 3, 4. The examiner can tick the method even if you slip later. Write it down, don't just think it.
Quick win. A 10-second checklist you can use every time. I call it the draw check. Draw the arrow, write the components, rearrange head to tail in your head, add or scale the components, verify by substitution. Practically, draw A and B, subtract to get AB, write R equals A plus lambda D, then substitute lambda equals 0 and lambda equals 1 to check you get A and B respectively. That second part takes 10 seconds and catches most sign mistakes.
Quick substitution check example. If R equals 2 minus 1 plus lambda 3, 4, put lambda equals 0 gives R equals 2 minus 1, which is A.
lambda equals 1 gives r equals 5, 3, which is b. If those don't match your original points, you've mixed up a sign or an order.
Worked example. Here's an exam-style question, and I'll talk through the marks as I go. Question. A has position vector 2, minus 1, and B has position vector 5, 3. In I1, find the vector AB. In I2, hence write the vector equation of the line through A and B.
Step 1. AB equals B minus A. Write the subtraction. 5, 3 minus 2 minus 1 equals 3, 4. That step is M1, method shown. Step 2. Write the vector equation. R equals 2, negative 1, plus lambda, 3, 4. That's the second M1 for using the format R equals A plus lambda D. Step 3. Check by substitution. Lambda equals 0 gives A, lambda equals 1 gives B, so A1 for the correct final answer. 3 steps, 3 marks, and you can see exactly where each mark comes from. So, common marking pitfall, students sometimes write R equals set of brackets 5, 3 set of brackets plus lambda set of brackets minus 3 minus 4 set of brackets, which algebraically represents the same line but written from B going towards A. Examiners accept that if shown clearly, but you still must show how you formed the direction vector. Show your subtraction to be safe. Practice challenge. Quick one for you to try now. Grab a pencil and paper. Find the vector CD and the vector equation of the line through C, 1, 2 and D, minus 2, 1. You've got 60 seconds. I'll pause. Go. Time's up. If you did it correctly, you subtract D minus C or C to D, depending on the direction you want. CD equals D minus C equals minus 2, 1, minus 1, 2, equals minus 3 minus 1. So one convenient equation is R equals 1, 2 plus lambda minus 3 minus 1. Check lambda equals 0 gives C and lambda equals 1 gives D. If your CD came out the other way, that's okay. You can write the equation from D with the opposite direction vector. Just show how you got the vector and include the parameter. Marks are awarded for method and clarity. That's your quick win for today. Draw, write the components, head to tail, and substitute to check. If this helped, share it with a friend who's revising. You'll find more worked solutions and printable practice vectors at jcacademyonline.co.uk. Until next time, trust the process and nail that exam. Stay curious.